Here we have an equation. It's a typical equation, a function equal to a constant, 1, and we want to prove that there is only one solution to this equation in this interval 0, 1. All right? The only problem is that this function is defined as an integral, and this integral cannot be expressed in terms of elementary integral. So you cannot find a primitive of this function. All right, so what do we do then? Well, this function here is continuous, therefore f is continuous and differentiable. It's both, right? You know that because of that's part of the fundamental theorem of calculus. All right, so with this information we can try to prove everything. As a matter of fact, we can consider the interval 0, 1, and then we have a continuous function in 0, 1, right, in this closed interval, and we apply Bolzano to begin with. So we calculate f of 0. That is easy because it's the integral from 0 to 0 of this function, and that integral is equal to 0 because the length of the interval is 0. And then we can also calculate f of 1. Well, actually, we can't calculate f of 1 because we don't know what is the primitive of this function, but we do know that e t squared is larger than 1 for any value of t, right? Okay, because, well, any value of t other than 0. So if t is different from 0, which means that this is larger than the integral from 0 to 1 of 1 dt, right? Because if the integrand is larger than this, so this function is larger than this one, the integral of this function in one interval is larger than the integral of this function in the same interval. So if we have this and this is 1, then we know two things. We know that f of 0 is smaller than 1, and that f of 1 is larger than 1. So 1 is an intermediate value between f of 0 and f of 1. And the function is continuous, so there must be a point C where the function reaches the value 1. So at least there is one solution to the equation. Are there more solutions? Well, actually no, because if we take the derivative of this function, that derivative is easy to calculate. It's just this. And this function is always positive, which means that f is always increasing. So if it crosses the line x equal to 1, y equal to 1, right? It never crosses it again, because from then on, on the right of C, the function takes only larger values than 1. So there's only one solution to this equation. There's a solution, right, that we've proven using the intermediate value theorem, but there's only one solution because f is increasing.